In this presentation, we have talked about Compton effect. Before entering into the topic Compton effect, we should know the fundamental properties of a photon. Photon belongs to Bose-Einstein statistics. The mass of the photon is 0. So massless boson is called a photon. The response of the photon is 0, even though it exerts momentum. The prime question is, how does a particle of 0 mass exert momentum? Compton gave a prompt answer to this question and was awarded the Nobel Prize. The Compton effect proved that a photon exerts momentum even though its response is 0. Now we will go to the Compton effect. The striking illustration between a photon of energy h nu and an electron of light element such as carbon is called Compton effect. To understand more about this, consider this paragraph. When high frequency radiations like X-rays or gamma rays fall on matter, a part of the radiation is scattered without any change in wavelength. Still, another part of the radiation comes out with a longer wavelength than the incident one. This is known as Compton effect. We wrote this first two lines. When high frequency radiation like X-rays or gamma rays, frequency high means wavelength low, because C equal to nu lambda, velocity of light equal to frequency into wavelength. Frequency is nu equal to C by lambda. If frequency is high, wavelength is low. They are inversely proportional to each other. If frequency is more, energy is also more, because E equal to h nu. E equal to h nu. So longer wavelength provides less frequency. Less frequency means low energy. When high frequency radiations like X-rays or gamma rays fall on matter, a part of the radiation is scattered without any change in wavelength. Still, another part of the radiation comes out with a longer wavelength. Comes out with a longer wavelength means lower frequency. This means that the incident light provides some amount of energy to the target. This is known as Compton effect. Now we have to find out the Compton shift. One compartment is having wavelength lambda, another one compartment is having lambda dash. The difference between these two is our d lambda. This is called as Compton shift. To understand more about this process, we have to go through this paragraph. Consider a photon of frequency nu and energy h nu collides with an electron at rest in the target. Suppose this is a target, and if you consider an electron in the target, a photon of energy h nu is allowed to interact with this target. A part of its energy is given to the electron and the remaining energy is given out as a scattered photon. The incident photon provides some amount of energy to the target and removes an electron from the target. After supplying some quantum of energy to the target, that photon comes out of the system with lesser energy. The electron, after gaining energy, comes out of the system with a velocity v. Initially the electron is at rest. Once after getting energy from the photon, the electron comes out of the system with velocity v and makes an angle pi to the direction of the incident photon. This is incident photon direction. The electron is coming out of the system in a particular direction. The direction makes an angle pi to the initial direction of the photon. At the same time, the path of the scattered photon makes an angle theta with the incident photon. If m0 is the response of the electron, then its mass while moving with the velocity v is m. Moving mass is m. Suppose the electron is at rest in the target, its mass is m0, called as rest mass. After gaining energy, the electron is coming out of the target. At that moment, its mass is m. Moving mass equal to rest mass divided by root of 1 minus v square by c square. Now we have to solve this problem with the help of conservation of energy and momentum. Now see this energy table. The energy of the photon before scattering is h nu. After the scattering process, the electron comes out of the system with less energy. So the energy of the photon after scattering is h nu dash. Initially the electron is at rest inside the target. Then the rest mass energy of the electron is m0 c square. After gaining energy from the photon, the electron energy is increased to mc square, where m is the moving mass. Now, according to conservation of energy, energy before scattering should equal energy after scattering. Now, see this table, see this diagram. Incident photon energy is h nu. Then the outgoing photon energy is h nu dash. It comes out of the system with new energy h nu dash. Initially, the electron is at rest. The rest mass energy of the electron is m0 c square. After gaining energy from the photon, the electron moves with velocity v. So the energy of the electron is mc square. Now, according to conservation theorem, energy before scattering equal to energy after scattering. Energy before scattering, we are having two particles. One is photon and another one is electron. Now, energy of the photon before scattering is h nu. Energy of the electron which is at rest is m0 c square. Then energy after scattering, energy of the photon is h nu dash. Then energy of the electron is mc square. See this equation? The photon is coming with energy h nu. After losing some amount of energy to the rest electron, it comes out with energy h nu dash. Initially the electron is at rest. The rest mass energy of the electron is m0 c square. mc square is the energy of the moving electron. M is moving mass, m0 is rest mass. According to conservation of energy, energy before scattering should equal energy after scattering. Now this should be modified as h nu minus h nu dash plus m0 c square equal to mc square. Just have brought this term to this side. Now this is modified as mc square equal to h nu minus h nu dash plus m0 c square. Then this is further modified as h into nu minus nu dash plus m0 c square. This is the value of mc square. Keep this as equation 1. Now take the square of this equation 1. M square c power 4. which is equal to h square nu minus nu dash whole square plus m0 square c power 4 plus 2 times h into nu minus nu dash m0 c square. This is a, this is b. A plus b whole square is equal to a square plus b square plus 2ab. So this is equation number 2. Keep this as such. Now come to our momentum part. The x component of momentum is going to be analyzed. Before scattering, the x component of momentum of the photon is h nu by c. How do you get h nu by c? See this table. We know that the energy of the photon is E equal to h nu. According to Einstein mass energy relation, E equal to mc square. So mc into c equal to h nu. Mass into velocity is photon. M into c is equal to p, that is equal to h nu by c. So momentum of the photon is h nu by c. Before collision, before scattering, the photon is moving along the x direction, so its momentum is h nu by c. After the scattering process, the momentum of the photon is h nu dash by c into cos theta, because the energy of the photon before collision is h nu. The energy of the photon after the collision is h nu dash. Then if you talk about x component of momentum, see this diagram. The scattered photon makes an angle theta with the initial direction. Usually the cos theta term is taking place along the x direction, sin theta term is oriented along the y direction. So the momentum of the photon is h nu by c in general. The incident photon energy is h nu. The momentum of the incident photon is h nu by c. The energy of the scattered photon is h nu dash. This is energy. The x component momentum of the scattered photon is, this is px, which is equal to h nu dash by c into cos theta, because the scattered radiation makes an angle theta. Now come to our electron. Initially the electron is at rest. Before scattering, the momentum of the electron along the x direction is 0. After the scattering, the momentum of the electron is mv cos pi. X component of momentum. See here. Initially the electron is at rest. After getting energy from the photon, the electron comes out of the system and makes an angle pi with the initial direction. The velocity of the electron is v. Then the mass of the electron, moving mass, is m. So mv is a momentum. We are talking about the x component of momentum. Along the x direction, cos term is taken place. So mv cos pi is the x component of momentum of the electron. See, this is the x component of momentum. According to conservation of momentum, momentum before scattering should equal momentum after scattering. Here, momentum of the photon, x component of momentum, is h nu by c. X component of momentum of the electron is 0 because the electron is at rest. Here, momentum of the photon, x component of momentum of the photon is h nu dash by c into cos theta. Then x component of momentum of electron is mv cos pi. Now we have to get an equation. See here, multiply all the terms by c. We can get h nu by C, not C, multiply all the terms by C. We can get h nu equal to h nu dash cos theta plus mbc cos pi. This is the new equation we can get. So write down this equation here. With the help of this, we can construct a equation, that is, write down the equation once again. H nu by C equal to h nu dash by C cos theta plus mv cos pi. This is the equation. Provide some number for this. Already we have given 2. This is 3. H nu by C equal to h nu dash by C cos theta plus mv cos pi. This is equation 3. This equation is modified as h nu equal to h nu dash cos theta plus mvc cos pi. Just multiply each and every terms by C. H nu by C into C, h nu dash by C into cos theta into C, h nu dash cos theta, mvc cos pi. From this, mvc cos pi, which is equal to h into nu minus nu dash cos theta. This is equation 4. H nu minus h nu dash cos theta. So h into nu minus nu dash cos theta. Now come to the y component of momentum. See, the photon is moving along the x direction alone. So the y component of momentum of the photon is 0. The electron is at rest, so the y component of momentum of the electron is 0. After the scattering process, the photon momentum along the y direction is h nu dash by c into sin theta, but the x component of momentum is h nu dash by c into cos theta. See this diagram. It makes an angle theta. The scattered photon makes an angle theta. X-axis carries the cos theta term, whereas the y-axis carries the sin theta term. Therefore, h nu dash by c into sin theta is the momentum of the photon. If you talk about the momentum of the electron recoils. So the momentum of the photon along the y direction is minus mv sin pi, whereas the momentum of the electron along the x-axis is mv cos pi. But the momentum of the electron along the y-axis is y direction is minus mv sin pi, because the electron recoils. Now consider this table. The photon is moving only along the x direction, so the y component of momentum of the photon is 0. Electron is at rest, therefore y component of momentum of the electron is also 0. After the scattering process, the sin theta term is oriented along the scattered photon, so h nu dash by c sin theta. If you are concentrating on y component of momentum, then y component of momentum of the electron is minus mv sin pi. According to conservation theorem, momentum of the photon before scattering should equal momentum of the photon after scattering. Here, momentum of the photon, y component of momentum 0. Then momentum of the electron along the y component, that is also 0. here momentum of the photon h nu dash by c into sin theta. Then momentum of the electron minus mv sin pi. From this equation, simply we can write h nu dash by c into sin theta equal to mv sin pi. See here, left hand side is 0, right hand side is 2 terms, one term is having negative side, so h nu dash by c sin theta equal to, if it comes to this side, it is mv sin pi. Then this is cross multiply with c, mvc sin pi equal to h nu dash sin theta. This is equation 5. Now find out 4 square. 4 square gives m square v square c square cos square pi, which is equal to h square into nu minus nu dash cos theta is nu minus nu dash cos theta whole square. See, directly we have applied mu minus nu dash cos theta whole square. Now this is equal to h square nu square plus nu dash square cos square theta minus 2 nu dash cos theta. Here the left hand side is m square v square c square cos square pi. Make the square of equation 5. 5 square gives m square v square c square sin square pi, which is equal to h square nu dash square sin square theta. Say this is equation number 6, this is 7. Now find out the value of 6 plus 7, adding these two, m square v square c square. Take this one common term, m square v square c square as a common term, then cos square theta plus sin square theta equal to 1. Here h square nu square plus h square nu dash square cos square theta minus 2 h square nu dash cos theta plus h square nu dash square sin square theta. This is equal to, here m square v square c square, this is h square nu square plus h square nu dash square. If you take h square nu dash square as a take out as a common term, cos square theta plus sin square theta, that is equal to 1. Write down once again, cos square theta plus sin square theta. Just I am combining these two terms, minus 2h square nu dash cos theta. This is equal to h square nu square plus h square nu dash square cos square theta plus sin square theta equal to 1 minus 2 h square nu dash cos theta. This is m square v square c square. Provides a number to this equation. This is 8. Now come to our equation 1. This is equation 2. M square c power 4. Find out the value of, write down the equation 2 here. M square c power 4. M square c power 4 equal to h square into nu minus nu dash whole square plus m0 square c power 4 plus m0 square c power 4 plus 2h into 2h into nu minus nu dash m0 c square. Verify 1 second. 2h into nu minus m0 c square. This is equation number 2. Now find the value of 2 minus 8. Equation 2 minus 8. This is m square c square into c square minus v square. Here m square c power 4 is present. Here m square c square v square is present. Take out m square c square term outside. So the c square, we are subtracting equation 8 from 2. Therefore m square c square into c square minus v square, which is equal to, write on this term, h square nu square plus nu dash square minus 2 nu dash plus m0 square c power 4 plus 2h into nu minus nu dash m0 c square minus h square nu square minus h square nu dash square plus 2h square nu dash cos theta, just minus of these terms. This is equal to h square nu square plus h square nu dash square minus 2h square nu dash plus m0 square c power 4 plus 2h into nu minus nu dash m0 c square, then minus h square nu square minus h square nu dash square plus 2h square nu dash cos theta. Now we have to simplify. This is equal to, here m square c square into c square minus v square. This is equal to see this, cancel these terms, positive, negative, then write in the remaining terms minus 2h square nu dash plus 2h into nu minus nu dash m0 c square plus 2h square nu dash cos theta plus m0 square c power 4. Now this should be further simplified. This is equal to minus 2 h square nu dash. Take this term outside. 1 minus cos theta. Just combine these two terms. This one and this one. Take minus 2h square nu dash outside. So here 1. Then minus of cos theta. Furthermore, add on this term plus 2h nu minus nu dash m0 c square plus m0 square c power 4. This is m square c square into c square minus v square. This is actually m square c square into c square minus v square. Now we have to find out the value m square. M is equal to m0 divided by root of 1 minus v square by c square. Then m square equal to m0 square divided by 1 minus v square by c square. This is equal to m0 square divided by cross multiply c square minus v square whole divided by c square. That comes here. Now instead of m square we have to substitute this value in the above equation. Say provide some number for this equation. What is the last number we have given? 8. Say this is equation 9. In equation 9 replace m square by this value m0 square c square divided by c square minus v square. Instead of m square we have to put m0 square c square whole divided by c square minus v square, and here on c square is present, into c square minus v square, which is equal to minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash m0 c square plus m0 square c power 4. Say this is equation 10. In this equation, see here m0 square c square into c square c power 4. So this is m0 square c power 4. This c square minus c square minus c square cancelled out, which is equal to minus 2h square nu dash into 1 minus cos theta plus 2h nu minus nu dash m0 c square plus m0 square c power 4. This is equation number 11. Now if you bring this m0 c power 4 to the left hand side, then entire is cancelled on the left hand side. We can cancel these two terms. Therefore minus 2h square nu dash into 1 minus cos theta plus 2h into nu minus nu dash m0 c square equal to 0. If you bring this term to the left hand side, m0 square c power 4 minus m0 square c power 4 equal to 0. This is equation number 12. Now 2h into nu minus nu dash m0 c square equal to 2h square nu dash into 1 minus cos theta. This is cancel 1 2 and 1h. Now this is modified as nu minus nu dash divided by nu dash equal to h divided by m0 c square into 1 minus cos theta. So this is equation number 13. See here, I am maintaining nu minus nu dash here, bringing this nu by nu dash to the left hand side, that is coming to the denominator. Then keep this m0 c square to the right hand side, it is h divided by m0 c square into 1 minus cos theta. Now this is modified as, see here, 1 by nu dash minus 1 by nu. This is nu by nu dash minus of, just I have written for your better understanding. I have to write it. Nu by nu dash minus nu dash by nu dash, which is equal to h divided by m0 c square into 1 minus cos theta. Now this is modified as 1 by nu dash minus 1 by nu, which is equal to h divided by m0 c square into 1 minus cos theta. Say this is equation number 14. Multiply both sides of equation 14 by c. C by nu dash minus c by nu, which is equal to h by m0 into c. Here c square, c by c square, that is c. Actually this is c, this is c square into 1 minus cos theta. Is c by nu dash minus c by nu, which is equal to h divided by m0 c into 1 minus cos theta. You know that velocity of light c equal to frequency into wavelength. Therefore c by nu equal to lambda. Then this term is written as lambda dash, this is lambda dash minus lambda, which is equal to h divided by m0 c into 1 minus cos theta. Here there is d lambda, change in wavelength, d lambda equal to h divided by m0 into c into 1 minus cos theta. This is called the Compton shift. Here m0 is the response of electron, c the velocity of light, h the Planck's constant, theta is the angle of scattering. Therefore from this equation we may conclude that the Compton shift or the change in wavelength depends upon the angle of scattering. It is not depending upon the nature of the radiation or the wavelength of light falling on the metal surface. The Compton shift does not depend on the wavelength of incident light and the nature of the material. It depends on the angle of scattering. The affecting factor is theta. Say if theta equal to 0, what is the value of d lambda? Cos 0 equal to 1. So the value of d lambda equal to 0. The incident light is coming out of the system as such. There is no change in the wavelength. If theta equal to 90 degree, if theta equal to 90 degree, cos 90 degree equal to 0. Therefore, d lambda equal to h divided by m0 into c. If theta equal to 180 degree, cos 180 degree equal to minus 1, then d lambda equal to h divided by m0c into 1 minus 1. This is equal to 2h divided by m0 into c. Therefore, we may conclude that the Compton shift depends upon the angle of scattering.